Okay, so now we've given 11 marks for a maths test. And I put them in order because I know what we're going to do next, which is find the interquartile range. So finding the interquartile range is pretty much you need to split the data in half first. So to split the data in half, you want to find the median. So I put them in order. If I cross them off one at a time till I get either one number in the middle or two numbers in the middle, that would be the median, or Q2 if you prefer. And this splits the data into two halves, and Q1, the lower quartile, is the median of the first half of the data set. So this half there. So we form the same thing again, cross off, till left with something in the middle. That is Q1. And the upper quartile is the median of the second half of the data set. So this half, so cross off one at a time, and that would be Q3. And the reason I did that is because the interquartile range is equal to Q3 take away Q1, which is 19 subtract 13, and for me that is 6. An interquartile range gives you a measurement of how spread out the data is, and that's going to be handy for this next part. So we have Sunil did the same 11 maths tests. The median mark Sunil scored in his tests is 17. The interquartile range is 8. Which one of Sunil or James has the more consistent marks? So consistency means the marks are closer together, and for me, James would have the best consistency because James's interquartile range is 6, Sunil's interquartile range is 8, 6 is less than 8. So you had to make a comparison between interquartile range. If you mention the median, again, that doesn't really do anything. That might give you who's actually the better mathematician, but not necessarily who's the most consistent. Okay, in part C, we have Sunil did 4 more maths tests. His scores in these 4 tests were 16, 20, 18, and 10. How does his new median mark for these tests compare with his median mark of 17 for the 11 tests? And for this one, because median is the middle number, once you put them in order, and his old median was 17, given there, you've got two numbers which are less than 17, and you have two numbers which are bigger than 17, so therefore the middle number is exactly the same. So the new median is still 17. And the only thing you had to do, you didn't have to work it out and put it in order, wherever you needed to do. All you needed to do was state that two numbers were below the median and two numbers above the median, therefore the median is unchanged. So you got two numbers below and two numbers above, therefore the median is unchanged. And this question is out of 5. Okay, last question on the paper is a cumulative frequency question. And you're given the weights of 80 adults, and the groups are 40 to 50, 50 to 60, all the way up to 100 to 110. Frequency tells you how many adults are in each group, and you're asked to complete the cumulative frequency table. And normally you just add your own column. Just add your own column on the side and do that. But they've given you the column to fill in. And yeah, pretty much you just do it. But some people might notice that the groups in the second table are slightly different, but pretty much there's no difference. All it's telling you is cumulative frequency would be from 40 to 50, i.e. the first row. The second one would be 40 to 60, i.e. the first 2 rows, and 40 to 70, the first 3 rows, 40 to 80, first 4 rows, and so on. Okay, so it's just reminding you of the method of adding up the rows. But yeah, we've got 11, add on 21, 32, add another 21, 53, add on 18, 71, 78, and 80, and that number there matches up with the number of adults, which means I've probably done it correct. Okay, right. Now the table. Now the key thing is when drawing a cumulative frequency diagram, the x-coordinate is not the midpoint of these groups. For a cumulative frequency diagram, it is the biggest number, the number on the right. So I'm going to be doing x-coordinate, y-coordinate, x-coordinate, y-coordinate, x, y, x, y, x, y, x, y, x, y. Okay, just the numbers at the end. Okay, and cumulative frequency goes on the y-axis. So first one is 50 across, 4 up. Not the best scale ever, but 54 is there. 60, 11. 60 across, 11 up. Then 70, 32. 70 across, 32 up. Looks like it's around about there. 80, 53. 90, 71. Probably should do this in pencil. Uh, 178 and 110, 80. You get this. And then all you want to do is draw either a smooth curve going through those points or connect them with straight lines. Whatever you do, don't do a line of best fit. It's not a scatter diagram, it's a cumulative frequency diagram. So I'm going to go for the smooth curve. Something like that. Okay, part C. Use a graph to find an estimate for the number of adults with weight more than 85 kilograms. Okay, well 85 kilograms is there. If I scroll up to see what that would be as a cumulative frequency, that is 62. So that means there's 62 adults who weigh 85 kilograms or less, according to my diagram. But I want the number of adults who weigh more than 85. So I've got one line of workings to do. There's 80 in total, 80 adults in total. I've just said 62 of them weigh 85 or less, and 80 subtract 62 is 18. And then part D, last thing on the paper is use a graph to find an estimate for the interquartile range of the weights of adults. Well, Q1, you're looking at the 25% of the number of adults, so 25% of 80. So you're looking at the 20th adult. Q3 is 75% of 80. So you're looking at the 60th adult. And you've got to show evidence that you're using your graph. So I'm going to find the 20th adult, which is there, scroll across. Which for me would give you Q1 being 66. Then 60th adult, scroll across. Is 84. And the interquartile range would be Q3 take away Q1, or 84 take away 66, which would give you 18. And that was over 7. Okay, if you've got any questions about any of these, then let me know. For some of these, they were tolerances. So in the mark scheme, they said I could only give correct answers for something between 2 numbers. So that might be a reason why you've got some of these wrong towards the end of this paper. But any questions, just post it in the Teams chat and I'll get back to you.